Hi, today I'm going to show you how folding this piece of paper solves the polynomial 4x cubed plus 2x squared minus 2x minus 1 equals 0.
First of all, draw a point in the middle, then draw a line 4 units to the right. Now turn the paper 90 degrees and draw a line 2 units to the right. Now turn the paper 90 degrees again and draw a line 2 units to the left. Finally, turn the paper 90 degrees and draw a line 1 unit to the left.
And now you have a weird line through your paper. That's called a Lil's path.
Now you're going to draw a line parallel to the first 2 unit path. That's 4 units to the right of it. Draw a line parallel to the second 2 unit path. That's 1 unit below it. Fold the paper so that the first point matches with the first line and the end point matches with the second line. Draw a line between that line and the first point.
And that's your answer, really. Get a compass and measure the angle. It's about 35.26 degrees, and negative tangent of that is about negative 1 over square root of 2.
Guess what plugging in negative 1 over square root of 2 gets us? It's 0. If I fold it this other way, I get negative 35.26 degrees, which gives me another answer, positive 1 over square root of 2.
This method, created by Margarita Balogh, works for literally any third-degree polynomial. Don't underestimate the progress of math, though. Balogh lived quite a while ago and created this origami method in 1936. But even then, there were definitely ways of finding roots of cubic polynomials. Formulas with radicals that are similar to the quadratic equation for cubics have been around since at least the 16th century. Still, this is a really cool and visual way to do it. It goes like this. Let's say that we have a polynomial ax cubed plus bx squared plus cx plus d, where a, b, c, and d are placeholders for our coefficients.
Let's draw a point in the middle, then draw a line a units to the right. So if a is positive, go to the right. If it's negative, go to the left. Turn the paper 90 degrees counterclockwise and draw a line b units to the right by that same rule. Then repeat step 2 for c and d. Now you have that weird line, so we're going to draw a line parallel to the b length path. That's 2b units away from the starting point. Draw a line parallel to the c path, that's 2c units away from the end point. And fold the paper so that the first point matches with the first line, and the end point matches with the second line. Draw a line between that line and the first point.
Get out a compass, measure the angle, and take the negative tangent of it. Try it out for yourself to prove that it works, but why does it work? Well, it uses two things. An old solution called Lil's method, and the Balogh fold.
Lil's method is a way to solve any polynomial by making these paths. It doesn't stop at third-degree polynomials. You just keep rotating and drawing lines until you run out of coefficients. If a laser is shot from the first point at angle theta, that's reflected at a right angle from any line segment and refracted at a right angle from the line that each segment is on, ends at the end point, then that negative tangent of that angle theta is a solution. It's pretty easy to see that using lasers and turtles, but much harder to do on a piece of paper, which is why Balogh used origami. Let's say you're given any 2 points and any 2 lines. The Balogh fold is a single fold that simultaneously puts each point on a different line.
What that does for us is to create the middle segment of that Lil's path, and then all we need to do is fill in the rest to find that magical angle theta.